You know that moment you turn the key in your car or you twist the throttle on your bike? There's that roar, that vibration, and suddenly this huge piece of metal is alive and ready to go. Well, that roar, it's the sound of controlled chaos. So let's peel back the metal and see what's actually going on in there. It really comes down to this one question, right? How can a simple liquid like petrol unleash enough force to move thousands of pounds of steel? I mean, it seems almost like magic, but it's not magic. It's just a brilliant piece of engineering that turns a flammable liquid into pure, powerful motion. And the answer lies right here, in the internal combustion engine. The most important word there is internal. See, unlike an old steam train that has its fire on the outside, here, the fire, the combustion, happens inside the engine itself. We're talking thousands of tiny, perfectly timed explosions every single minute. So, to really get how this amazing process works, we're going to take a journey deep inside the heart of the most common type of engine out there. Okay, we're zooming right in on a single cylinder. You can think of this as the main stage where all the action happens. And inside, we've got the piston. Its entire job is just to move up and down, over and over and over again. And believe it or not, that simple, relentless motion is the foundation for every ounce of power your vehicle makes. But that up and down movement isn't just random. Nope. It follows a very precise, repeating rhythm, a kind of four-step dance called the four-stroke cycle. And this is the fundamental secret behind pretty much every car and motorcycle engine on the road today. The four steps are intake, compression, power, and exhaust. Now there's a really easy way to remember this. Suck, squeeze, bang, blow. Let's break down what each of those means. First up, we've got intake. Now keep your eye on that valve at the top left. The piston starts at the top and moves down. As it does, that intake valve opens up, creating a vacuum that just sucks a mix of air and petrol right into the cylinder. This is the suck part of our cycle. Next up is compression. Now watch this. Both of those valves slam shut. The piston then travels back up, squeezing that air and fuel mixture into a super tiny pressurized space. This squeeze is absolutely critical because it makes the mixture incredibly volatile, just packing it with potential energy that's waiting to be released. And that brings us to the main event, power. You see that little spark plug up top? With the mixture all compressed, it lets out a tiny spark. That spark ignites the mixture, causing a massive explosion that violently forces the piston right back down. This is the bang. And that one single violent push downwards, that's the whole point. That's the moment that generates all the force that eventually turns the wheels of your vehicle. And finally, you got to clear out the smoke, right? That's exhaust. The other valve, the exhaust valve on the right, pops open. As the piston moves back up one last time, it pushes all those used up, burnt gases out of the cylinder. This is the blow phase, clearing the stage so the whole show can start all over again. So here it is, the whole sequence in motion. Suck, squeeze, bang, blow. Over and over. And remember, this isn't happening in slow motion. This four-step dance happens thousands of times every single minute in every cylinder of your engine, creating that smooth, continuous power that gets you down the road. Okay, so now that we've got the basic recipe down, suck, squeeze, bang, blow, we can start to understand the different flavors of engines that are out there. Because, not all of them follow this exact same recipe. The two most common types you'll hear about are petrol and diesel. Now, we just saw how a petrol engine uses a spark plug to create that bang. A diesel engine, well, it does things a little differently. It actually gets rid of the spark plug entirely and uses something called compression ignition instead. So in a diesel engine, only air gets sucked in during that intake stroke. Then it gets compressed way more intensely than in a petrol engine. I mean, look at that compression ratio. It gets squeezed so hard that the air becomes incredibly hot. Then, at just the right moment, diesel fuel is sprayed in, and it just instantly explodes from the sheer heat of the air. No spark needed. This higher compression is what makes diesel engines more efficient, letting them squeeze more energy and more miles out of the same amount of fuel. Now, what if you could get that power stroke, that bang, to happen more often? Well, that's the whole idea behind the two-stroke engine. And as this quote says, for its size, this thing is an absolute powerhouse. A two-stroke engine is super clever. It combines all four steps into just two piston movements, one up, one down. So it gets a power stroke for every single revolution of the crankshaft, which is twice as often as a four-stroke. It uses simple openings called ports instead of complex valves, so it's way lighter and simpler. So why don't we use these in cars? Well, that simplicity comes at the cost of efficiency and, frankly, emissions. For things like scooters and chainsaws where you want a ton of power in a tiny package, they're perfect. But for a car, the smoother, cleaner, and more efficient four-stroke design is still the king. So why does all of this matter? What's the takeaway here? Well, because now you can look at the world of cars and bikes and actually understand the language they're speaking. So next time you look at a spec sheet like this one, terms like engine won't just be a bunch of random numbers anymore. You'll see 249.6 cc, and you'll know that cc, cubic centimeters, is talking about the total volume inside those cylinders we just explored. It's a measure of the engine's size. You'll see things like liquid-cooled and four-valve, and it'll all make sense. And now you can see how it all connects. A bigger cc number means a bigger cylinder, which can suck in more air and fuel. That leads to a bigger bang during the power stroke, and ultimately, more horsepower. See? It all goes right back to that simple four-stroke cycle we just learned. And you know what's cool? This ability to decode technical info doesn't have to stop with the engine. As a little bonus here, just take a look at the numbers on your tire. They might look like a random code, but just like an engine spec sheet, they tell a whole story. Everything from the tire's width to the size of the wheel it fits on. It's all part of the same language of engineering. So, from this simple, repeating cycle of tiny, controlled explosions, the internal combustion engine literally moved the entire 20th century. It changed everything. But now, as we're seeing the rise of electric vehicles, it leaves us with a really fascinating question to think about. What new technology, what new kind of engine will be the one to define our time?